All right, so we're going to talk about isosceles triangles and some of the angle properties that they have, and then we're going to talk about the measures of angles of polygons. Specifically, sums are the measure of the sum of all the angles of a polygon. Okay, so let's get started. All right, so remember that an isosceles triangle is a triangle. I always misspell it. I would leave that one S. Is a triangle that has two sides that are equal in length. And if you look at the picture here of the isosceles triangle, we can describe everything that's happening here using this picture, right? So these two lines mean that those two sides are equal. So that makes this an isosceles triangle. And, excuse me, and if you look at the other side away from those two equal lines, this one, that one is going to be called the base. And these two angles on the base are called the base angles. Makes sense because that's the base, right? The very top is called the apex. Not super important for you for what we're going to study. Mostly what we want to look at is simply this idea of, I need some better color here, this idea of the base and the base angles. So those are the things that we're going to be talking about the most, the base and the base angles. And those two things lead us to what's called the isosceles triangle theorem, right? You don't need too fancy a language of this. You just need to be able to identify these things and find the missing pieces, all right? So, and here's what what the theorem says, that in any isosceles triangle, the base angles are equal. So that means the angles that are attached to the base and those two equal sides are always going to be equal, no matter what. And slightly less important for us, but we need to know it, the line joining the apex to the midpoint of the base makes a right angle. So in other words, if you cut an isosceles triangle in half from the apex, meaning that point where those two equal lines meet, all the way to the base, you're always going to get a right angle. So what you can do is you can cut these in half and create two right triangles out of them. Okay? Now, that's not going to help you too much at this stage of your mathematics, but it's going to make a huge difference when you move to year 10 and year 11 where you do some trigonometry. Okay? So, the big deal is that the base angles are always equal. So it's important for us to be able to find the base angle and then to know that they are always going to be equal. Okay? All right. So let's look at how that can be used. Now, these are called the converses. You don't have to worry about that. But if a triangle has two equal angles, then it has to be isosceles. So in other words, if these two equal sides make these equal, it's like a scowly face, then if you have two equal angles, that automatically makes the sides that they're connected to above them equal as well. So it's just the converse or the opposite of, right? So you can read it backwards and forwards. If two things are equal, they have to be equal in both directions, okay? And that the angle bisector always makes a right angle. So that's the same thing we talked about before, okay? So let's look at how we can use that. So here, I don't know this angle. So this is x degrees. But these two lines tell me that this is an isosceles triangle. And so if it's an isosceles triangle, if that one is x degrees, then this one is also x degrees. Yeah? So we could use a little algebra to be able to solve that. Because I have x degrees and 38 degrees. Now, so what I'm going to do is, if I know that the first base angle plus the second base angle plus 38 degrees always has to add up to 180 degrees because all of the measures of a triangle, all of the angles of the triangle have to measure and create 180. All right? So if that's the case, then I can just do a little simple algebra. We'll combine those two like terms, so that becomes 2x's plus 38 equals 180. Subtract the 38 to get the x terms by themselves, the x term by itself, I'm sorry. So that gives us 2x equals, what is that going to give us? 142. Then divide it by 2, which tells us that x is equal to 71 degrees. So that tells us that each one of these angles is 71 degrees. So by knowing that they're the same, I can then use some algebra to solve them just by calling them each x. But remember, you have not just one x, you have two that are the same size, so 2x's. Okay. Now you can do the same with our knowledge of exterior angles. Remember that with exterior angles, I know that if this is an exterior angle on a triangle here, and I know that that is the sum of this angle and this angle added together will give me that one. Now my problem is that I don't know those, but I can find them again by doing some algebra. So let's look through that algebra so that we can see what we have to do. So first of all, if that's 52 degrees, I know that that inside angle has to also be 52 degrees. So 180 minus 52 minus 52, now you could have added those up first if you wanted to and gotten 100. So that's 180 minus 104. Subtract that. Tells you that P is 76 degrees. All right? Then just add these two together, and that'll give us our x. So actually, we didn't even have to use algebra. We could use just simple arithmetic for that one. Okay? So by knowing that these two are the same, we were able to... Oh, I messed that one up, didn't I? Look at that. Do you see what I did? I didn't read it carefully. And the one I was using as the other base angle is not the base angle. So here are my equal sides. So that's a base angle and that's a base angle. Therefore, this is just the sum of those two. So the 104. Sorry, guys. I did that on purpose to make sure that you were paying attention. Not. Okay. All right. So be careful. So there you go. Get your 71. You got your 104. Right? So pay close attention to where these are. Don't just assume this is the base because it's sitting on it. In this case, this side PQ was the base. Okay? So you're going to have a few exercises where you're just going to find these. And some of them, they give you a little more algebra to do, but that's good practice. Okay? So that's one thing we're going to do. The next thing we're going to do is we're going to talk a little bit about some polygons. And the first one we're going to talk about is quadrilaterals. And we're not interested in what the names are so much or anything. We're going to work with a lot of quadrilaterals in future lessons. What we're interested in right now is how to deal with the angles. But if you'll remember, a quadrilateral is simply a polygon which has four sides. Remember, a polygon is simply a closed shape that has all straight sides. Okay, so this is a polygon. And any one of them that has exactly four sides is called a quadrilateral. And if you'll notice, every quadrilateral can be split into two triangles. And we can use that information to find the sum of the angles. Okay? And here it is. The sum of the interior angles of a quadrilateral is 360 degrees. And again, that's because it's two triangles at 180 degrees each. So that makes 360 degrees. So if you know some of the angles, you can find the other by knowing that they all have to add up to 360 degrees. Okay? So here we go. I know these two, and I know that one, even though it's just a box. That means that's 90 degrees. So if I add those three that I know up, right, and then subtract it from 36 degrees, they used a little algebra here, but you don't have to. You could just use arithmetic. And that tells me that the missing side is 62 degrees. Okay, pretty straightforward. So you'll have a couple of those. And let's see. Don't worry too much about the properties of these. We're not going to go into that right now. The properties of a kite, don't worry about that. We're going to drop down to no midpoints. The angles of any n-sided polygon. Now, the beauty of polygons is no matter how many sides they have, they can be turned into a bunch of triangles. And this is really important skill for you guys. So make sure you know. And depending on how many triangles you make, that's going to give you your multiplier. But it always follows a pattern, okay? So let's look at the chart. Let's look at this. We'll do this drawing first. So here we have a polygon that has 1, 2, 3, 4, 5 sides. And I can cut it into 3 different triangles. Now that's not the only way you could cut it into 3 triangles. That makes no difference at all. But notice that you can cut it into 3 different triangles. Well, with a quadrilateral, I could only cut it into 2 triangles without making crossing lines. We don't want any crossing lines. So for a quadrilateral, which has 4 sides, I can make 2 triangles. Therefore, 2 times 180 is 360. For a pentagon, that's a 5-sided object, I can make 3 triangles. So the pattern here is simply 3 times 180 degrees, or whatever that is. Okay? So octagon has 8 sides. Okay? So no matter how many sides it has, it's just the number of sides minus 2 will tell you how many triangles you can make, and then you multiply that number times 180 degrees to tell you the sum of the interior angles. Okay? So it doesn't matter how many sides a polygon has, right? So for a 20-agon, whatever that is, for a 20-agon, it has 20 sides. Therefore, it has 8. You could make 18 triangles, right? It's always 2 less. So 18 times 180 degrees would give you the sum of those interior angles. Okay? So the sum of the sizes of the interior angles of any n-sided polygons is n minus 2 times 180. The number of sides minus 2 times 180. Now, and the reason that's important is it allows us to then investigate how many the missing sides, find the missing sides. Now, here we have 132 here. We know that that square means that's 90 degrees. We have 3 x's, so 3 x's, and the 132 plus 90 is 222. And because it has 1, 2, 3, 4, 5 sides, that becomes 3 times 180, so we know that they all should add up to make 540. And then using simple algebra, we know that all 3 of those missing angles are 106 degrees. Make sure you put degrees on there when you do that, okay? All right, so we're going to look at a few of these and find the sums of the angles and find some missing angles. All right, so now that's a lot of space in the book we've covered, but not a lot of big ideas, not a lot of different ideas. So let's go back and find out what assignment we want for you. Okay. So we're going to start with 9C. That's where those isosceles triangles start on. So that's page 179. And I'm going to put this on as an assignment. So page 179, exercise 9C. I want you to do number 1 for sure. It's got some exterior angles in there too, so that's a good one. Oh, that's plenty. I'm not real worried about those two. Okay, then go down to 9D1. Definitely want you to do number 1. It's on page 181. Okay, number 1's fine. We're not going to worry about the properties of those special quadrilaterals because we're going to look at that a lot when we do area and volume, etc. So you're just going to drop down to page 186. That's exercise 9E. I want you to do 1 and 2. Let's do 1 through 4. Just do 1 through 4. Okay? All right, so let me come back and see you guys. Okay? So, our last lesson on angles. Looks good? Maybe?
Thank you.
Okay, and then what we're going to do is, so I'm going to put this assignment up, and I want you to upload your answers. I need some evidence that we're doing work, so I want you to upload your answers. Hopefully next week, at some point, maybe we'll be face-to-face again, and then I can just walk around and see your answers like I normally do. But for now, I need, and call on you. But for now, I need to have some kind of evidence that you're doing your work. Now, so I'm going to put these assignments up on Teams. So they'll come to you as an assignment on Teams, so you'll know exactly what it is I expect. You'll upload your answer there. If you cannot upload your answer there, then you can send me a picture of it and email it to me. But I would really prefer you get to upload it if you can, okay? So try to make that work. If it doesn't work, then let me know. But I know other teachers have been doing it. But give it a shot. It's not that difficult. And just so I can have the evidence. Now, evidence means that it can be used against you, right? So I need to see the working, or you're going to get a nice little email saying, where's your working? Then you'll get a nice little email saying, where's your working? And it'll have your name and your caregiver's name at the top. Okay? So make sure that you're working on, that you do your working and you turn it in. I'm sorry, I've got a message in between there. It made me lose my train of thought. Okay? All right, so I'm going to stop the recording.